Hello everyone, this is Mirzai from Calpoly Pomona, and in this lesson we're going to continue the discussion of utility theory. In the previous video we had the problem of calculating the utility function for a Kickapoo given a bunch of lotteries. So what we did, we allocated 0 to the lowest outcome and 1 to the highest outcome. We set up equivalent lotteries for the numbers in between, and we estimated his utility function, or basically his behavior toward risk. But sometimes you don't have these numbers in between. You basically want to estimate someone's behavior toward risk without any given lotteries. So how do we deal with setting up a utility function for quantifying someone's behavior toward risk if you don't have any of these lotteries in hand? In this lesson, we're going to talk about that. We assume that the least favorable outcome has a utility of 0, and the most favorable outcome has a utility of 1. So that means that we have to have the least favorable outcome and the most favorable outcome, but we won't have anything in between to set up our utility function. So in this case, what we have to do, given that we do have the best and the least award that we can receive, we set up an equivalent lottery, where in one side, you always use 1/2 and 1/2, basically 50-50% chance of winning the most favorable reward, and 50% chance of winning the least favorable reward. You have to find out what number here makes these two lottery equivalent. So if you remember in the previous scenario where we had all the lotteries, what we did, we had to come up with the probabilities here. But in this case, where we don't have those in-between numbers, we set up the probabilities as 50-50, and we try to find this number. So whatever number we find here gives you a utility of 1/2, because we know that this utility is 1, this utility is 0, so the expected utility from here is 1/2. So whatever number we put here is going to have the utility of 1/2. So basically we find the midpoint in our utility. So in this case, you have to ask the user what reward in this side makes these two lottery equivalent. Let's say the person says negative 3,400 makes these two lotteries the same. If I have a 100% chance of losing $3,400, it's going to be equivalent to winning $30,000 with probability of 50% and negative $10,000 with the probability of 50%. So in this case, this value here, negative $3,400, is going to have utility of 1/2. So now we're going to continue this process, but this time instead of using the maximum reward, we use the reward that has a utility of 1/2. And the idea is to find the value that makes these two equivalent. This is going to have a utility of 1/2, and this one has a utility of 0. The expected value from here, which is 1/2 multiplied by 1/2 plus 0 multiplied by 1/2, is going to be 1/4. Whatever number we find for this is going to have a utility of 1/4. So we have to ask the person what reward here, if you get with probability of 100%, makes these two lottery exactly the same for you. Basically, you wouldn't having any preference for one over the other. So let's say this case, the person says it's negative $8,000. So again, there's no specific rules or calculation for these. It's purely the perception of the person about the lotteries and how they feel about it. In the next lesson, we say that these perceptions have to follow some certain rules for us to be able to use this method for calculating the utility. If the person is a little bit irrational or illogical, then some of these steps might not fall into the right place, and we're not going to have a smooth utility curve. We're going to talk about it in the next lesson, but for now, accept that these X values that we find in this case is purely based on how we feel about these two lotteries and what makes it for us equivalent. So in this case, the person says, if I lose $8,000 with a probability of 100% is the same as losing $3,400 with probability of 50% or losing negative $10,000 with a probability of 50%. So in this case, this negative $8,000 utility is going to be 1/4, because in the previous step we showed that the utility of negative $3,400 is 1/2, And also we know the utility of negative 10,000 is 0. So if we calculate the expected utility from this equivalent lottery, it's going to be 1/4. So now we have a few points. We found out utility of highest reward is 1, which in this case is, let's say, $30,000 has a utility of 1, and negative $10,000 or losing $10,000 has a utility of 0. And we found two midpoint here. So we found the utility of 1/2 is associated to negative $3,400, and 1/4 is related to losing $8,000. So we can come up with a kind of like a curve that shows the utility of this person. If we plot this, allows us to find a utility function here, then we are able to find out the utility of any other values for this person. So we need to find a few points to be able to plot this curve. But if we do it right, or if the perception of the person is based on our assumption and the way that he comes up with the numbers is following a certain rule, then we can have a very smooth utility curve. Otherwise, if you see some of these points are not exactly falling on a smooth curve, it's probably because some of the assumption or axioms of utility theory is not followed or violated here. With this, our lesson has concluded. Please refer to the next video for understanding what are the axioms that we have to follow as we come up with these numbers. Also, refer to your blackboards for your assignments. Thank you.